Hello everyone, here we're back with the essence of regression. And what I want to talk about today is an important assumption in multiple regression called independence of errors. So let's talk about that. The first thing I want you to note is that we're going to keep this real simple for talking about the independence of errors assumption. So we're going to have a model that's going to have one predictor variable in it, job satisfaction, and we have an outcome variable of organizational commitment. And so let's start with that, and we'll talk about the independence of errors assumption. Okay, so to begin, I'm going to draw a graph for you. So here is our y-axis, our vertical axis, and then here is our x-axis, our horizontal axis. And on the x-axis, we're going to have our one predictor variable, job satisfaction. So here it is, job satisfaction. And on our y-axis, we're going to have our outcome variable. So that's organizational commitment. So here's organizational commitment. All right. And so now what I'm going to do is I'm just going to go crazy now here, putting in actual observed values on the outcome variable organizational commitment. So here we go. And each one of these dots is an actual observed value on the outcome variable organizational commitment. And each one of these dots is an actual observed value on the outcome variable organizational commitment for a particular participant in our sample. And we said we had 100 participants. I don't know we have 100 dots here yet or not, but let's say that we do. Okay? So each one of these dots is an actual observed value for a participant in our sample. So we have 100 participants in our sample, 100 participants in our sample, 1 through 100 participants in our sample. And for each one, we have an actual observed value on the outcome variable measure. This is a measure along with the measure of the predictor variable that we handed out, let's say, to 100 people, and they filled out the measures, and we got a score on the job satisfaction measure for each of our participants. We actually scored the measure. We also got a score on the outcome variable measure for organizational commitment. We got that measure back from people. We actually scored it. So we have an actual observed score on the outcome variable organizational commitment. And we have that for each of our participants. We have 100 participants. So let's say we have 100 actual observed scores here then on the outcome variable organizational commitment. Now let's just take a closer look at one of these observed scores on the outcome variable. I'll actually blow it up a bit for you here. What that dot actually is it's a combination of the X and Y scores for any particular participant, this particular participant in this example, in our sample. So this particular participant got a particular score on job satisfaction. So right here, and so we can say right here, and that same participant also got a score, an actual observed score on the outcome variable organizational commitment. And so if we take that on over here, we have a score here on organizational commitment for that particular participant. So that's what each one of those dots actually are. It's a combination for each of our participants of their score on the predictor variable in the model, job satisfaction, and their score, their actual observed score on the outcome variable, organizational commitment. All right, now let's just go ahead and do something else here. We're just going to go for it. We're going to draw a regression line, which, by the way, is a reflection of the regression equation, which I talk about in other videos. And this regression line is sometimes referred to as the line of best fit because, in fact, here, let me go to another marker, have it stand out for you a bit here. So here is the regression line. Line of best fit is drawn through our actual observed values. And do my best job. My best job there to have that be a straight line, which it should be. Here, let's take that off a little bit there. And it displays the overall linear relationship between the outcome variable organizational commitment and our predictor variable job satisfaction. And it's mathematically determined where it's going to be drawn through these actual observed values on the outcome variable measure so that it is as close as possible to these actual observed values overall, close as possible overall to these actual observed values. That's why it's called the line of best fit. Okay, so here's our regression line. And on that regression line are predicted values on the outcome variable measure coming from our model. Okay, and so coming from our model, or the information that we have on each of our participants of their degree of job satisfaction, a prediction is made as to what each participant's value will be on the outcome variable, organizational commitment. So we also have a predicted value on the outcome variable, along with an actual observed value on the outcome variable, score people actually got on the outcome variable measure on organizational commitment. But we have a predicted value on the outcome variable, organizational commitment, from the model based on person scores on the predictor variable measure, or their degree of job satisfaction. So based on that information about each participant in the model. Now, where do you find those predicted values from the model, you ask? Well, they're found right along this regression line. They're like right on the regression line. And I'm just drawing, a few here. We have 100 predicted values, just like we have 100 actual observed values on the outcome variable measure. And they're all along this regression line. Okay? And by the way, I'm going to kind of give you a hint as to something I'm going to say later. You'll notice that I brought these predicted values all the way out here. Well, one thing that's true in regression, and I talk about this in one of the other videos, is that every observed value has a friend. And so we can't have that predicted value there without there being an accompanying actual observed value on the outcome variable measure. So let's put those in. There we go. Don't want to have our observed values being lonely. It just isn't nice to do to them. They have a social need just like everybody else does. And so every observed value has a friend, and that's the corresponding predicted value from the model. So we got the friend there in place. for each of those observed values. Observed value, predicted value. Observed value, predicted value for any particular case. Okay. Any particular participant in our sample. Okay, now I want you to notice what we have so far. We have, let's say we have a measure of job satisfaction. That's our predictor variable measure. Okay, that information, the degree of job satisfaction that we have in the model for each of our participants. And let's say that that score ranges on the measure anywhere from 1 to 10. And we see here for our first participant in the sample that their score on the job satisfaction measure was an 8. And let's say the participant 1 happens to be this participant right here, the one we were using as an example earlier. And so we said, well, that participant has a particular score on the job satisfaction measure, and we know what that score is. It's 8. So let's put that in right here. Okay? And so that's an 8 right there. Okay? Corresponds to this particular participant, participant number 1, let's say, who got a score of 8 on the job satisfaction on that predictive variable measure for job satisfaction. Okay, and then in fact we can start to replace these letters here now with actual values. So that's an 8 on the x variable here, was on the x-axis. That's the person's score on the predictive variable measure for job satisfaction. Okay, and then let's see, what was their y value or their actual observed score? Their actual observed score on the outcome variable measure. Well, for our first participant, their actual observed score or value on the outcome variable organizational commitment was 7. And so we take that over here to the y-axis. This is the score for organizational commitment, and we have a 7. Okay, and now the question is, we have the predicted value out of the model based on the information we have in the model in terms of the person's degree of job satisfaction. Now, this is a reflection here of the regression equation, because in the regression equation we not only have for participant 1, if we apply the regression equation to participant 1, their score on the job satisfaction measure, but we also have a regression coefficient which tells us the relationship between the predictor variable, job satisfaction, and the outcome variable, organizational commitment. And we also have a constant which we add in. And so so after we do that, after we complete the regression equation for participant 1, we will get a predicted value on the outcome variable organizational commitment, which again is based on what we know about participant 1's degree of job satisfaction. Okay, that particular information that we have on participant 1 as well as the rest of our participants. And the predicted value that is coming out of the model, what the model predicts participant 1's value or score would be on the outcome variable organizational commitment, is 5. Okay, so where is that predicted score? And you can go ahead and think about where that predicted score is. Well, it's right here. Let's see how you bring this up here. So you bring it on up. And here, let's actually have it be right here, because this would be then in line with that 8. So there we go. Okay. And so that, for participant 1, is the predicted value out of the model based on what we know about their degree of job satisfaction as to what the person's score would be on the outcome variable organizational commitment. That's what the model predicts that participant 1's score, a participant's 1 score would be on the outcome variable. But here is participant 1's actual observed score on the outcome variable, organizational commitment. So we see that the predicted score coming out of the model, based on our knowledge of the degree of job satisfaction of participant 1, it's not the same as the actual observed score, the score that participant 1 actually got on the outcome variable measure for organizational commitment. And so how do we represent that difference? Well, here we go, folks. This is what it's all coming down to. How do we represent that difference or that error in the prediction? Well, we go like this. There we go. There's the predicted value out of the model based on our knowledge of the degree of job satisfaction for participant 1. Here is participant 1's actual observed score on the outcome variable measure for organizational commitment. And that is, that predicted score is from the actual observed score on the outcome variable measure. Here's the predicted score is 5. Actual observed score is 7. Well, the predicted score is 2 units away from the actual observed score. That's our residual, or our error in prediction. And so that value is 2. That's our residual, or otherwise called our error in prediction, or how far away the predicted score from the model is from the person's actual observed score in the outcome variable measure. It's 2 units away. The predicted score is 5. The actual observed score is 7. That's a residual of 2. Okay, well, notice then something that we have here, which is that we have 100 actual observed scores. Actual observed scores are values on the outcome variable, organizational commitment in this example, for each of our 100 participants. We also have, because every observed value has a friend, a corresponding predicted value based on what we know about each participant's degree of job satisfaction, a predicted value from the model as to each of our participants' score on the outcome variable measure, organizational commitment. So for participant 1, there's the predicted value from the model, but we have that predicted score for each of our 100 participants. So we have 100 of those predicted scores from the model. And we also have 100 residuals, right? We have 100 errors of prediction. So here's and let's make sure now. Remember, every observed value has a friend. We got to get an observed value in there. The two always go together, these predicted scores from the model and the actual observed score on the outcome variable measure. So here's predicted score from the model. Here's the actual observed score on the outcome variable measure. And the difference is the residual, whatever that difference may be. And here we have another residual right here. These are all small residuals so far. How about, here? Here's the predicted score out of the model. Well, the model predicts the person's score would be on the outcome variable measure, organizational commitment. That's the predicted score right there. And then here is the person's actual observed score, that same person's actual observed score on the outcome variable measure. And so here we got a residual there, kind of a squiggly line there, but that's the difference between the predicted value of the model, the actual observed score on the outcome variable measure. That difference is the residual or the error in prediction. This one's actually quite large. And we have that for each of our participants. So we have also 100 residual values. Okay, so now that you have a good sense of what we mean by the residual or the error, an important assumption in multiple regression is that we have independence of errors or independence of our residual values. And so what that assumption is, and by the way, it is an extremely important assumption in regression. Our other assumptions, in one way or another, can be usually cleaned up if they're not met. So there are several assumptions in regression, but if they're not met in one way or another, we can usually clean it up and we're okay. But here, the independence of errors assumption is a critical assumption for regression. We need to meet it if we're going to be using multiple regression, just ordinary, everyday, standard multiple regression. We must meet the independence of errors assumption. And it is saying that, for example, this residual is separate and independent. So this residual value is separate and independent from this residual value. And this residual value is separate and independent from this residual value. And when we say separate and independent, we mean uncorrelated with or independent of. And this residual value is independent of, uncorrelated with, this residual value. And on we would go for all of our residual values, that for any two residual values, they are in each and every instance, and we just go on here with our residuals, right? Well, in each and every instance, they are uncorrelated with each other. They are separate and independent of each other. Now, that's what the independence of errors assumption means, that our residuals or our errors in prediction, are separate and independent from one another. They stand alone. They are uncorrelated from each other. So for any two residual values, they are uncorrelated. But there's an additional thing for you to know as part of this assumption. And that is how it works out is that if you meet the independence of errors assumption, what that means, hand in hand with meeting the independence of errors assumption, is what that is also saying is that each of these actual observed values on the outcome variable measure, any two of them, are also separate and independent from one another. That they are also uncorrelated with each other. Okay, so the assumption is stated in terms of independence of errors or independence of our residual values, but it has direct implications for the independence of our actual observed scores on the outcome variable measure. And so if the residual values are separate and independent from one another, uncorrelated with each other, what that also means automatically, hand in hand with it, is that our actual observed values, okay, our actual observed values on the outcome variable measure are also separate and independent from one another, or uncorrelated with each other. Now, I like to think of the independence of errors assumption in that way because it forms the basis, and I'm just going to mention this quickly to you because we're about the essence of regression here, so I'm not going to get into some other statistical procedure, but it forms the basis for how critical the independence of errors assumption is for even doing just a standard, regular, just ordinary, everyday multiple regression. Because if you do not meet the independence of errors assumption, which means that your residual values are actually correlated with one another. They're related with one another. They don't stand separate and independent from one another. What that also means is that your actual observed values on the outcome variable measure are also correlated with each other. They also do not stand separate and independent from each other. And that's a problem, because if that happens in just a regular, everyday, ordinary multiple regression procedure, you cannot have confidence in your significance tests. They may be way off. And so what you need to do instead is you need to go over to some other statistical procedure like multi-level modeling, which takes into account the correlation between the errors. Or put another way, the correlation between the actual observed values on the outcome variable. And only then, taking into account those correlations, can we have confidence in our significance test. But again, that means stepping out into an entirely different, although, well, statistical analysis, like multi-level modeling. I say entirely different because it is a very different procedure in terms of running it and the types of things that you'll be considering, although it is also a form of regression. So it's not that different, but the point is you're not doing multiple regression in just a standard, ordinary, regular form anymore. Okay, so the independence of errors assumption, really important for multiple regression. I wish you a good one. Till later. Oh, I'm being asked by my producer to sign this. We like to do that. It's part of our ongoing tradition here to do that. So let me go ahead and do that. There we go. I'd like to do a picture on this if we can. Well, if I can. I'm the one doing it. No we here on this one. There's a we here on the rest of this production. It's a team effort. But on this thing, it's me. So let's just see how I can draw here. There, we get a hat. Well, low brim hat is over my eyes. So let's see, we got kind of a top thing to the hat there. And then let's see, we go like this, kind of, you wouldn't see the glasses above here, would you? So, you know, again, I didn't get high grades in art school. But those are supposed to be glasses. And there you go. And maybe I got, I don't know, some hair here. Can you imagine that? Long time since I've seen much hair on me. Here, I guess you got hair coming out from behind, underneath the hat. That's a lot of hair. That's been quite a while since I've seen that. But anyway, you got some hair happening here too. Must be back in my much younger days. All right. Have a good one.